Hello, today we are going to discuss on the topic syntax directed definition. Let's begin. Before knowing what is an STD or syntax directed definition, we need to know what is a context-free grammar and semantic rules. Context-free grammar is nothing but the grammar which is accepted by a context-free language, and the semantic rules are the conversion of a variable to its real values. Basically, a syntax directed definition or an STD is a combination of both these things, that is context-free grammar and semantic rules. That is, STD is equal to CFG plus semantic rules. And every grammar is associated with its attributes. Attributes is nothing but the alphabets or the symbols associated with the grammar, which is represented as sigma, and the semantic rules are always associated with productions. Productions are production rules of a grammar. And if X is a symbol or an alphabet in a grammar, then X dot A implies its real value. An attribute or an alphabet may include numbers, strings, references, data types, etc. It may include numbers, strings like A, B, C, D, 0, 1, 2, 3, data types, etc. And here is an example for production and semantic rules. Production is E implies E plus T, E implies T, and its corresponding semantic rule is E dot val is equal to E dot val plus T dot val, E dot val is equal to T dot val. Here E dot val and T dot val represents its original values, the original value of E and T. Our next topic is types of attributes in STD. We have already discussed what is attributes and what are to be the attributes like strings, numbers, data types, etc. Okay, an attribute may be a string, data type, numbers, etc. And there are basically two types of attributes, which are synthesized attribute and inherited attribute. The first one is synthesized attribute. If a node takes the values from its children node, then it is called synthesized attributes. For example, if a production rule is there and the parent node is take value, its actual value from its children node, then it is said to be synthesized attribute. Here is an example, a production rule. A implies BCD. A is a parent node and BCD as a children node. Okay, and its corresponding semantic rules are A dot S equal to B dot S, A dot S equal to C dot S, and A dot S equal to D dot S. Here the parent node A accepts value from the children nodes B, C and D. Okay, then the A attribute is a synthesized attribute. Then the second type of attribute is inherited attributes. We have learned what is a synthesized attribute, the attribute which accept value from its children node, right? So in inherited attribute, the node which takes or accepts values from its parent or either in the sibling node. Okay, the node or the attribute which accepts a value, the real value from its parent node or sibling node is called as inherited attribute. Okay, here is an example. The production rule is given. A implies BCD. Here A is a parent node and BCD are siblings. Okay, and its corresponding semantic rule is C dot S is equal to A dot S and B dot S is equal to D dot S. In the first semantic rule, C dot S is equal to A dot S. C is the children node which accept value from the parent node A. Okay, here A is a parent node and C is the children node. So the condition is satisfied. And in the second semantic rule, B dot S is equal to D dot S. Here B is a children node and D is a sibling of B. Okay, so the attributes which accept only parent node or sibling node is called inherited attributes. The next topic of our session is types of STD, types of syntax directed definition. There are basically two types of syntax directed definition. The one is S attributed and the another is L attributed STD. The first one is S attributed STD. We have already studied what is a synthesized attribute. You know what is a synthesized attribute? Synthesized attributes are those attributes or those nodes which accept the value only from the children node. Such attributes are called synthesized attribute. An STD or a synthesized directed definition which uses only synthesized attributes are called an S-attributed STD. Here in S-attributed STD, the S represents the synthesized attribute. Okay, the STD which uses only synthesized attributes are said to be S-attributed STD. Here is an example. A production rule is given. A implies BCD. Here A is a parent node and BCD are the children node of A, and BCD are siblings. Okay, and its corresponding semantic rules are given. A dot S is equal to B dot S, A dot S is equal to C dot S, A dot S is equal to D dot S. These are the semantic rules given. Here A is a parent node which accepts value from B, C and D. Okay, B, C and D are the children nodes of A, so A is a synthesized attribute. So what is an S-attributed STD? The STD which uses only synthesized attributes. Here A is a synthesized attributes in which it accepts only values from its children node B, C and D. Here the semantic actions are always takes place in the right end of the production. Okay, here in the production the semantic actions are takes place in the right side, that is in the BCD, right hand side of the production. The next type, the second type of STD is L-attributed STD. We have already discussed what is an S-attributed STD. The STD which uses only synthesized attributes is S-attributed STD. But in the case of L-attributed STD, it uses both the synthesized and inherited attributes. We have know what is a synthesized and inherited attributes. The STD which use both the synthesized and inherited attributes is said to be an L-attributed STD. But the problem is, in the case of an L-attributed STD, it can only accept values from its parent or left siblings only. Which means that if a node is there which cannot accept a value from its right sibling, it can only accept values, inherited values from its parent or left siblings only. It is restricted to inherited from its parent and left siblings only. Here is an example. Here is a production rule. A implies X, Y, Z. It is a production rule. A implies X, Y, Z, and its corresponding semantic rules are Y dot S is equal to A dot S and Y dot S is equal to X dot S. Here in the case of first semantic rule, Y dot S equal to A dot S, the Y is accept the value from its parent node, which is a synthesized attribute. And in the case of Y dot S is equal to X dot S, the Y attribute is accepting the value from its left attribute X. Okay, here Y dot S is equal to Z dot S, which is also a semantic rule, but it is not acceptable because Z is in the right side of Y, which is not acceptable. Okay, only the attributes which is in the left side of Y can be accepted in semantic rules. Here semantic actions can be placed anywhere in RHS, right hand side of the production rule. That's all about topic. We have discussed what is an STD, which are the types of attributes in an STD, which are the different types of STDs, and I hope you have all understood what is an STD and its types. Thank you.